Welcome to Solving Systems. Let's begin. So our essential question is, what is a system of equations and how do we solve one? So a system of equations is just a set of two or more equations. We'll mostly be working with two, but sometimes we'll get into three. Now, the solution for a system of equation is where it crosses on a graph. So one possible solution you could have, if you were to graph one of those equations and then graph the other one, this would be your solution point. Okay, that's your solution. You're looking for the point where they intersect. So one possible solution you could have is to get just one solution, so one place where they cross. Another possible solution would be if you graph both those lines and they never cross because they're parallel. So that would mean you had no solutions. And then the third possible type of solution you could get would be if you graph the lines and they happen to be exactly the same. It should be exactly the same. In this case, they would cross everywhere. So there wouldn't just be one solution, but you'd have infinitely many solutions. All right, so the system is just a set of equations. You're looking for where they cross or where they intersect. They could intersect once, never, or all infinitely many times. Now there are four ways to solve a system: graphing, by substitution, with elimination, or using a matrix. And we're going to go over all four of those ways here now. All right, so solving a system by graphing. You just want to make sure that your equations are in slope-intercept form. Remember, that's y equals mx plus b. Then you just graph them and find that intersection point. Just don't forget to write it as an ordered pair. So let's just try an example together. Here I've got y equals 2x minus 4. I'm going to use this blue color. Graph on the y-intercept, which is negative 4. Go up with the slope up 2 over 1. Okay, so there are my points. That's my line. And then I'm going to graph y equals negative x plus 2. These are both already in that y equals mx plus b form, but if they're not, then you would need to change it. And as you can see, they're going to cross right there at 2, 0. So your solution to this system is at 2, 0. So just a point about a system of inequalities. This would be a set of two or more inequalities together. So here we've got this inequality. Okay, you would graph it. Here's the dashed line, and then we shade it with the blue. Here's another inequality, solid line. You shade it with the red. So the solution for the system of inequalities is here, where they're both shaded. Okay, so any points in this double shaded area would be a solution to the system of inequalities. So just a reminder, when you find a solution for a system of inequalities, they need to be in the double shaded area where they're both shaded. And then points on a solid line are a solution, points on a dashed line would not be. So the second way that we solve a system is by substitution. Okay, the first thing you want to do is isolate a variable. So that means you want to get it either in y equals or x equals, whichever one's easier. Then you're going to substitute that into the second equation, whichever what the equation was that you didn't put into y equals or x equals. You'll solve to find the variable, and then you'll substitute that back in to find the other variable. And you need to write your answer as an ordered pair. So these steps might make a little bit more sense when you see the example. So let's go ahead and do an example. Okay, so remember we said we wanted to isolate a variable first. So I'm going to look at this first equation, and I know that if I subtract the 4, then I can get it into y equals. So that's what I'm going to do first. 3x minus 4. So now I have a y equals. I've isolated one of my variables. Now you just have to substitute. If y equals 3x minus 4, then in my second equation, then I can plug that in for my y. Because now I know that y equals 3x minus 4. So I plugged it right into here. And now I just need to solve for x. See, now I only have x values in this equation. So I can distribute 9x minus 12. I can subtract the 9 And this cancels, and I'll have negative 12. 6x plus 6, subtract the 6. Divide by 6, and I have that x equals negative 3. Okay, so that's half of what we need to do. We found where it's crossing on the x. We found x is negative 3. But now I need to go back and plug that in for this x so I can figure out what y is. So now I know that x is negative 3. So I found here that y is going to be negative 13. And then I don't just want to circle these two and be done. I want to write my solution as an ordered pair, because remember, it's where it crosses, where the two lines intersect on a graph. So that's how you solve a system by substitution instead of graphing. The third way is by something called elimination. Okay, so here are the steps. If you want to write them down, you can, or if you want to go back and write them during the example, you can. But this is different in that you want the equations to be in standard form. Okay, with graphing, we wanted slope-intercept form. With substitution, it doesn't matter. You're just trying to isolate a variable. With elimination, you need it in standard form, which is ax plus by equals c. So for example, like 3x plus 2y equals 10. That would be standard form if you've forgotten standard form. We want to look for variables that have the same coefficient. And this is important. If those variables have the same sign, we'll subtract. If they have different signs, we're going to add. Then we'll solve for both of our variables, and again, you write that solution as an ordered pair. So let's do an example. Okay, so these are already in standard form. Ax plus by equals c. Okay, so they're lined up. My x's and my y's and my constants over here. So I'm looking for a variable that has the same coefficient, right? These two y's have different coefficients. These x both have a coefficient of 1, so I'm going to work with this. Okay, now they have the same sign. They're both a positive 1x. So we're going to subtract. Now you need to be careful, because when you subtract the equations, it's easy to remember x minus x, but then to forget about it when you're doing 2y minus y. So I like to put this little parentheses just so I remember that you're distributing that x to every term in there. So again, x minus x, that's nothing, right? That's 0. So that's eliminating a variable. That's why it's called solving by elimination. And then 2y minus y is just 1y. And 5 minus 4 is 1. So this is a more simple example. Now that we know that y equals 1, we can go back and plug it into one of our equations. Doesn't matter which one. I'm going to pick the second one just because it looks a little easier to me. So x plus 1 equals 4. And I subtract that 1, so x has to equal 3. And again, write it as an ordered pair. Okay, so if I were to graph these equations would intersect at 3, 1. So here's one more example of solving by elimination. We have both of these equations already in standard form. I'm looking for the variable that has the same coefficient, so that would be my y's because they're both 8. But in this case, this is a positive 8 and this is a negative 8. So this one we're going to add. Okay, same sign, subtract, different signs, add. So 3x plus 2x is 5x. 8y plus a negative 8y, that's eliminated. 11 plus 4 is 15. Then I solve for x, so x is 3. Now I go back and plug that x in for something. I'm using the first equation, but it doesn't matter. 9 plus 8y equals 11. Subtract, oops, that's an 11. Subtract the 9, that's 2. And so y would be 1/4. So writing that as an ordered pair, it crosses at 3 and 1/4. Okay, so this is the last way we solve systems. We can use a matrix. Now we're going to learn how to do this in the calculator a little bit later, but I'll show you how you're going to set it up. The first thing is you want your equations in standard form. Just like with elimination, it needs to be in that ax plus by equals c form. And then we're going to write our matrices, put it in the calculator, and the calculator will give us that solution. We just need to make sure to write it as an ordered pair. So before I set it up, just a quick little review on matrices. A matrix is just a rectangular array of numbers. Okay, so you've got these little brackets, and you've got the numbers in there. Now, this one is a 2 by 2. Okay, where this one is a 3 by 3. We'll be working with both kinds, right? So 2 rows and 2 columns, 3 rows and 3 columns. Now, the 3 matrices we're going to use are coefficient, variable, and constant. Okay, so the coefficient is exactly like it sounds. You're just taking the coefficients of the equations and putting them in here in the same order. So 3 and -11, so you write it just like that, left to right, 3, -11, and then -2, 6. This is why it's really important to have this in the correct standard form. If the y's were on the other side, it's going to mess up your matrix. Now the variable matrix is whatever the variables are. So we have an x and then we have a y. So it would be x, y. And then the constants are the numbers over here, 4 and -7. Now we're trying to find x and y. Okay, that's what the calculator is going to give us. Now we'll enter this into our calculator as matrix A, and then we'll enter this constant matrix into our calculator as matrix B. And again, I'll show you that when we practice this in class. And this is our variable matrix. But when you enter in the calculator, you're always going to have to enter matrix A to the -1 times matrix B. Okay, that will give you our variable matrix x and y. It'll give you a number here for both of these variables. Do not forget that -1. It's very important. I'm going to show you here where it comes from. Just don't forget to always enter that in with the A. So doing the math, if you have matrix A times variable matrix equals matrix B, but we can only plug these into the calculator because we want to solve for this, right? This times this equals this. So we need to divide by coefficient matrix, right? Just doing regular algebra. So then you have that your variable matrix equals this B divided by A. Now anything that's on the bottom of a fraction, right, putting that little -1, you can bring it back up to the top. Okay, so this little -1 tells me that it also goes on the bottom of that fraction. And that's why we enter it like this in our calculator. I do the one first. I guess it doesn't matter which one you do first, but I'll always enter an A to the -1B. Okay, so that's where that A gets that little -1, and you can't forget it. But once you enter this, it will give you this variable matrix, and it'll have a number and a number, and you'll have found your solution with a matrix. So don't forget to write your summary and your questions. Go back to the video if you're getting stuck, and don't forget those 4 ways that we're going to solve systems: graphing, substitution, elimination, and with matrices. Thanks for watching. See you soon.